All righty, it is, if you can believe it, February 20th. We are rolling right through geometry for second semester and almost to the halfway mark for the semester, which sounds almost unbelievable. And after this week, we'll have 8 weeks left after today, and there's 15 total weeks in second semester. And so, yeah, so we're encroaching at least the midpoint of the semester, which is very, very good. Still a few, oh, what do you got? What, 8 and 8, 16, 15 total. So, yeah, as of next week, we'll be at 7. So we're right there and not quite there, but almost. And let's roll. Lesson 58 is a whole new chapter, thankfully, on the teaching textbooks curriculum, which I'm sure all of you are currently thriving doing, getting all the even lessons done in their entirety, getting 100% on all of them because that's the kind of students I have. And but we start in 58, a brand new chapter, and that chapter is about polygons with more sides. So we'll go. We did triangles for a while, then we did quadrilaterals for a while, and all the things, the rhombuses, parallelograms, things of that nature. Now we're going to go into uh, the next set, and we're going to do a bunch of them all together. And so let me go ahead and get the white screen going here so we can start drawing and talking and such. And all right, Miriam's coming in. By Miriam, I don't mean Miriam, Elisa's sister. I mean Miriam Alexander's sister. So we have two people in here with a sister named Miriam, and so did Moses and Moses' sister as well. Anyways, that's a different sermon altogether, though. Let's go ahead and just teach you a little bit about um, some of these extra polygons. Again, a polygon is an enclosed shape, and we've learned about triangles, which have 3 sides, 3 angles, quadrilaterals, which have 4 sides, 4 angles. Then we're going to go through the next group, which is going to be pentagons, of course, then hexagons, then heptagons, then octagons, and then nonagons, and then decagons. Okay, so let's go ahead and get the whiteboard out again and see if we can make some sense of that. Give some thoughts on these, some things that you kind of need to know. I want to write some of these down. And so let me just, first of all, number of sides, and then name. Pardon my terrible penmanship here. So 3, we have triangle. 4, we have quadrilateral. These are all polygons. 5 is a pentagon. Now, once you get into 5, we have the concept of a convex or concave. Does anybody know either of those words in even in different settings, different scenarios? The word concave or convex. Anybody? You can type it over if you don't, if you want to not jump on with your audio. Okay, like a skateboard has a little bit of concave to it. If you notice, I used to be a skateboarder. It had a little bit of curvature to it. And then so convex is the opposite of concave. So once we get into pentagons, they are either going to be concave or convex. And we're not going to get a lot into concave polygons. And let me just give you a pentagon shape real quick. Pentagon is a 5-sided shape. Okay, so this is convex because all the sides go out. There's no angles go in. And they're not going to talk about concave ones. They just tell you what they are. And then from here on out, we're going to talk mostly about almost exclusive of the convex kind. Okay, you could have a 5-sided shape that looks like this. 1, 2, 3, 4, 5. You see how this angle right here goes in, and it has one angle that actually kind of goes the opposite direction. And if you think about the angle inside of the actual um, polygon, it actually has a degree greater than 180, right? So these would both be acute. These could even be right angles theoretically. And then you have a five-sided shape. There's five sides, one, two, three, four, five. This is called a concave. Again, they're not going to explore those very much. Matter of fact, all they're going to do is just say this does exist. This is called a concave pentagon because there's one, two, three, four, five shapes. But for the most part, we're going to be talking about convex because of diagonals as well, because you'll see diagonals in these as well. And so I'm going to erase this. So concave, that's just something you might probably should write down, and convex, it is alluded to here in this lesson. And so, of course, the Pentagon, the building that's near Washington, D.C., I think it's actually in Virginia, I believe, but uh, it is the headquarters of defense for the United States of America. And the reason it's five-sided is because of the different branches of the government, of the military. And of course, we know the four major branches. And then, of course, the Coast Guard. You have the Army, Navy, Air Force, Marines, Coast Guard. Those are the five branches. The Pentagon was actually constructed. The idea of it was conceived during World War II and then constructed shortly thereafter. And it was wanting to get all of the military headquarters in the same location. And so they built the Pentagon. And on September 11th, 2001, of course, none of you were born yet, but I was, I don't know, how old was I? 30 something? Yeah, I was 29. Yeah, I guess I would have been, yeah, 20. So I don't know how old I was. 73. Yeah, I was 28, I guess. Um, that's when the World Trade Center was attacked with the planes in the North and South Tower of the World Trade Center buildings, building one and two. And then the Pentagon was also attacked, and a plane was flown into the Pentagon as well. So that was a attack on a terrorist attack on our nation. So, but the Pentagon is the largest square-footed building in in America, and it's not really tall. It's like 6, 7 stories tall is all, except it's so thick. And there's actually multiple layers of the Pentagon. If you ever look at an aerial cross uh, view of it, and I think, as I remember, the further you go into it, the higher your clearance has to be. So, like the generals and stuff are in the deepest, labyrinth of the Pentagon and the bowels of the Pentagon. So yeah, that's where the name Pentagon for the building itself is reference to the five-sided shape of the Pentagon. So the number of sides now is 6, and that would be, you may know. Of course, we know, Mr. Soto. Then we have the octagon at 8. I'll bypass 7 for a second. Some of that, ultimate fighter stuff has, the octagon. I don't know the difference much between MMA and, that's mixed martial arts, of course, and all the other ones. But one of them has a octagon shaped arena or ring cage match. So that's the shape of it. Should probably know more about that stuff, but I don't. Nonagon for 9. And then 10 is going to be a decagon. And this is a heptagon here, heptagon. All right. So those are all of the different shapes, and we'll be talking about those. There's a few different things in this chapter. The first one that they want you to know also is the number of diagonals. Now we're going to talk about convex ones for this, for number of diagonals. And this actually you have one, two, three, four, and okay. So you should have what? I think that's all of them. They start overlapping along the way, but there's actually a formula for number of diagonals. Remember, in a rectangle, there's just two diagonals, right? Corner to corner, corner to corner. Here you have looks like five. We'll make sure. One, two, three, four. Maybe it's just four. Well, look. The formula for diagonals is diagonals equals half the number of sides multiplied by the number of sides minus 3. So you just take the number of sides, like you could take, let's just take this quadrilateral, this rectangle to start with. There's 4 sides, right? Half, 4, 4 minus 3, 1, 4, 2, right? A half times 4 times 1 is 2. 2 diagonals. Let's do the same thing for now a pentagon. So all I gotta do is plug the number of sides in both ends. So we have a half times 5, 5 minus 3. So this is 2. Order doesn't matter, so let's go 2 times 5 is 10. 10 divided by a half is the same as, so 10 multiplied by a half is the same as divided by 2, which is 5. There's 1, 2, 3, 4, 5. Yes, 1, 2, 3. There's 5 total. Which one am I missing? 1, 2, 3, 4. I must be missing one because there's a 5th one there. 5 diagonals in a 5 times 3 is, yeah. So it's 5. 5 total. That's how you find out the number of diagonals in a polygon. So you could do any polygon. You could go, let's go nonagon. So it's half 9, 9 minus 3, 6. 6 times 9 is going to be 54. Half of 54 is 27. So a nonagon has 27 diagonals in it. So there you go. That's all free for you. Okay, so again, this is the first chapter of the first lesson of the new chapter. The new chapter has to do with polygons with 5 to 10 sides, which would be a pentagon, a hexagon, a heptagon, an octagon, a nonagon, and a decagon. Okay, so each of those has that number of sides. The ones we're talking about here are the convex kind, which means all the sides go out, none of them turn in. And I showed you an example how a concave one would look, and you could take any of those shapes, and if you have one or multiple sides that are in that go in, which makes the angles inside more than 180, then we know that those are concave. But we're talking about convex ones so far. So that's all the new teaching for you today. Anybody have any questions about that? That makes sense? Again, you probably talked about octagons already and pentagons and such. But so far so good. Thumbs up if you got it so far. 1, 2, 3, go. Ooh, lots of thumbs up. Thumbs down if any of that was confusing at all to you. All right, let's go into number 16 on your sheet there for 58. We'll do 16, 17, 18, 19, 20, 21, 22, and 23. See if we can make some sense of these things. Okay, so we're going to have to draw this triangle. It's going to be PLW. We know that the L is going to be the largest angle because it says it's 104. This is number 16. So we got to make this one, this angle here, might even do a little bit more than that. because we know that this angle is going to be kind of the bigger angle. It's with 104, right? Because it's L. Okay. All right. And now it's also going to tell us something about angle P, which is right here. Okay. So it's PLW. So I've drawn this shape, this triangle with an extended ray out on this side because I need this to be able to do some figuring here. So in my description, it says that the measurement of angle L is 104 and the exterior angle of P, which is this one here, is going to be 143. So if this is 143, I think this is going to be 37 if my math is good in my head. Let me double check. 180 minus 143 equals 40 minus 43. I'm sorry. Yeah, 180 minus 143 equals 37. So this must here be 37. Okay. They gave me this 104 degrees. They gave me this 143 degrees. I've calculated this to be 37. So I know that this is going to be 104 plus 37 minus 180. Okay. I hit the wrong button once. I had to redo it. Sorry about that taking so long. 39. Okay. They gave me this measurement. This is number 16 on lesson 58. It's on the top of your worksheet that I handed out. This is 104 degrees because they told me that. This is 143 because they told me that. I calculated this is 37. I calculated this at 39. Okay. What happens is this, and it might not be exactly the scale, but we know the smallest angle of a triangle produces the shortest side of the opposite. So LW must be the shortest side because it's the smallest angle. So PW is the biggest because it's opposite 104. LP is the second or the middle because it's opposite 39. And LW is opposite the 37. It's got to be the shortest side. There's your answer to number 16. Thumbs up if you get that. Pointer finger in the middle if you're kind of confused. Thumbs down if you're completely lost how I calculated that for number 16. Let me read the whole thing first. It says, in triangle PLW, the measurement of angle L is 104, and the measure of exterior angle at P is 143. Which is the shortest side of the triangle? The shortest side, of course, would be LW. All right? Thumbs up on the count of three, or thumbs down, or pointer finger in the middle. 1, 2, 3, go. All right. Lots of you getting it. Nobody doesn't get it. All right. Okay, so let's do 17 and 18. It says this. Using that figure above there. For each given statement below, select the definition, property, postulate, or theorem that justifies each proven statement. They've told us that side AE, or line segment AE, is congruent to IO, and AO is congruent to EI, which basically tells us it's a parallelogram. So that's what we want us to prove. They want us to prove that AEIO is a parallelogram. There's several different ways to prove it. One way to prove a parallelogram is the side theory. Okay. You can also do it by angles. You can also do it by diagonals. Okay. But since they told us about the sides being congruent, it's got to be the definition that says the sides are congruent. Okay. So of those five, A, B, C, D, or E, which one of those is the proof to number 17. Just give me A, B, C, D, or E. Read through them. Send me over your answer. I'm going to check a couple emails because I'm getting lots of emails coming through. Got music playing too. All right, nothing important. All right, I got a couple answers. Anybody else? A, B, C, D, or E? Again, in the definition, it's going to have to say something about the opposite sides being congruent because that's what they told us. They told us it's a shape. They told us the opposite sides are congruent. So if I'm going to prove it's a parallelogram, I have to know that the opposite sides are congruent. Which of, on number 17 of those 5 statements, says it's a quadrilateral, says it's also a parallelogram, and then mentions that the sides are congruent? A says this: if both pairs of opposite sides are parallel, parallelity doesn't matter, right? It's got to be congruent. Can't be A. Letter B, there's no diagonals mentioned. Forget number B. Letter C, angles. That would prove the fact that it's a parallelogram, but they've not told us about angles. They told us about sides, so it can't be C. E, if all the sides are congruent, then a quadrilateral is a parallelogram. It never told us that all the sides were congruent, though. It just told us that, and that would be a rhombus, by the way. It just told, and a rhombus is a parallelogram, so that could work, but they never told us that. They just said this is congruent to this, and this is congruent to this. And if both opposite pairs of a quadrilateral are congruent, then that quadrilateral is a parallelogram. For those who answered E on number 17, you are correct. Okay, let's do the same thing, but let's do it with number 18. A, B, C, D, or E. Again, they told you that it's a parallelogram to begin with. So now they've gone opposite. In number 17, they said these two sides are congruent to each other, and these two sides are congruent to each other. Prove that this is a parallelogram. Well, if opposite sides of a quadrilateral are both congruent to each other, then that quadrilateral is a parallelogram. This time they started off by saying, hey, this shape's a parallelogram. You can do the converse or the inverse of that by saying, well, if they told me it's a parallelogram, then I know the opposite angles are congruent. So what would it be? A, B, C, D, or E? I got to prove that the opposite angles are congruent. Which one of those says both opposite angles are congruent? It can't be A because they're not all congruent. Can't be B because it's not talking about sides, it's talking about angles. No mention of diagonals at all, so it can't be C. It's got to be D because it's congruent. It's trying for you to prove the opposite angles are congruent. If it first tells you it's a quadrilateral, I mean, that the quadrilateral is a parallelogram, then we know. Again, so let me just show you really quick. I think sometimes you guys just kind of balk at these proofs. This is not too difficult, okay? So in number 17, they said, hey, check out the shape, this quadrilateral. And they said, okay, let me tell you something about it. This side is congruent to this side, and this side is congruent to this side. Why don't you show me what proof you'd use to say that this AEIO is a parallelogram? Well, you go through all your theorems in your brain, you say, well, if both sets of opposite sides are congruent, then by definition, the shape's got to be a parallelogram. So the answer to number 17 was E. Well, for number 18, they said same shape, but they started off by saying, hey, this is a parallelogram. So what conclusions can I draw about it? Well, I could conclude that the opposite sides are congruent. I can also conclude that the opposite angles are congruent, which here they are. Okay. Now they say they want you to prove that A and I are congruent. Well, if it's a parallelogram, we know they are. And E and O are congruent. Again, if it's a parallelogram, we know that it is. Right? So all that, because they told me it's a parallelogram, it would be letter D for number 18. If a quadrilateral is a parallelogram, then both pairs of opposite sides are congruent. And that's what they're asking me to prove. All right, let's do this. Let's go on to number 19. Why don't you try to solve it? I'll give you the hint. The two angles are the same. Make the two solve for X. Simple algebra 1, maybe even pre-algebra problem. They give you angle B, they give you angle C, solve for X. That's all they want you to do. You may not have a paper, you need me to draw this out. I'm gonna go get a bottle of water while you do it. All right. My students are also smart. Good job, those who did it. All right. Again, 3x plus 9 is equal to 4x minus 3. Simple pre-algebra here. We know the two angles are congruent. If congruent means the same. To solve for an unknown value, you just basically split those by that. You subtract, let's do this. Let's subtract 3x from this side, subtract 3x from this side, add 3 to this side, add 3 to this side. And so that cancels out. That cancels out. 4x minus 3x is x. 9 plus 3 is 12. 12 equals x, or x equals 12. That would be the correct answer. Good job, those who did it. The next one is a double problem. This is a little bit tougher, okay? Let me show you what I mean. They give you x plus 10, 3y minus 3, x plus 7, 2y. Okay, so it's x plus 7. In order to solve for this one, you're going to have to do what, either use the substitution method with two variables or the elimination method. Or there's actually one other way you could do it if you remember how to do that. You could put both of them into the slope-intercept theorem, graph both of them, and where the two lines intersect will be your answers for x and y both, if you wanted to do that. But that's a lot of work. I don't think you're going to want to do that. But that would theoretically work, which is kind of fun, I gather. So what you're going to want to do is create two problems. 2y equals x plus 7. X plus 10 equals 3y minus 3. In my estimation, the easiest way to do it is to use what's called the substitution method. Get one of the variables all by itself. And then when you do that, what you're going to do is you're going to plug it into the other So you only have one variable because you can't solve a problem with two variables. Because remember this, let me just tell you this, kind of important. If you ever have two variables in an equation, there's unlimited number of answers. If x plus y equals 10, it doesn't matter. There's a trillion answers. You know, Mr. Soto, I don't think trillion is a word. But watch, if x is 2, then y is 8. If x is 1, y is 9. If x is negative 1, y is 11, right? And you could put any number, even 16 trillion, 548 billion, 300, whatever number you put in, y would be its counterpart, right? So that being said, because of that, you have to get one variable in order to solve, and that's how you do that. So I'm going to give you a chance to do that, and then you're going to give me the answers for x and y both, because that's what they want you to solve for number 20. All right. Good job, Hannah. That looks correct to me. You could also use an elimination method. If you so chose. All right. If you're still working on it, raise your hand. If you're completely lost on how to do it, put a thumbs down. Okay. Don't see who that is. Okay. Yeah, no worries. Let me show you how to do it. The math here is actually algebra. Okay. So if you didn't really do well in algebra, then maybe that's, or maybe if you didn't get all the way to the finishing the curriculum. Okay. I had one thumbs down. Nobody's still working on it. A couple people have sent me over answers. Let me show you how to do this. Okay. Again, there's several different ways to do it. But if you look here, I have two different variables. I need to get it to one variable. Okay. So what I want to do is this. I want to take this bottom equation, the 2y equals x plus 7, and I want to just get it equal to x. And I'll show you why in a second. But in order to do that, I just go like this. So 2y minus 7 equals x. Now, remember, x means the same on both sides. So in this problem up here, if x is equal to 2y minus 7, I can just, that's why I call this the substitution method. I can take this 2y minus 7 and substitute it for x. Now watch what happens when I do that. 2y minus 7, that's that x right there. If x is equals means the same. So instead of saying x, I put 2y minus 7 plus 10, because that's what the original problem says, equals 3y minus 3. Okay, now look at the problem now. We have only y. There's no x at all, right? So the x's are gone. So now I'm going to subtract. Let me combine like terms. So 2y plus 3, negative 7 and positive 10, equals 3y minus 3. Now all I'm simply going to do is subtract 2y from this side, subtract 2y from this side, add 3, Again, that's pre-algebra there. The first part was advanced algebra 1. Now I'm to just solving for y. 3y minus 2y is just y. So y equals 6. Once you have y's value, you plug it into the easiest problem that you have. I say the easiest problem you have is this. So you take the value of y that you just solved for and plug it in here. 2 times y is 12 equals x plus 7. Subtract 7, subtract 7. 5 equals x, or x equals 5. There's your two answers right there. Okay, now here we go. Thumbs up means you can do it without me. Pointer finger in the middle is now that you did it, Mr. Soto, I could see it and I could probably do it. Thumbs down is I'm still completely lost. On the count of 3, give me your sign. 1, 2, 3, go. Okay. Perfect. All right, lots of thumbs up. Good. Nice, 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 nice. All right, sometimes just seeing somebody do something helps you do it. And again, so number 21 is basically if it's a square, the angles are equal to 90. So the easiest way to do this is say that for the measurement of angle W to solve for P, 4P minus 2 equals 90, solve for P, then do 5Q equals 90, solve for Q. You're not even, this is pre-algebra. There's some more complicated ways to do it, but simply put 4P minus 2 equals 90. Why 90? Because it's a square. 5Q equals 90. Don't combine these together. Just solve for P by itself here. P equals this. Then solve for Q here. Q equals this. You don't even have to combine. This is very easy. All right. That's not too terribly difficult. I did those for you. Going once, going twice, sold. Number 22 looks hard. I want to give you just about 2 or 3 minutes to look at it. You're saying, Mr. Soto, they didn't give me any information at all. Okay. Yeah, good job, Miriam. You got those right. Okay. That's correct, Hannah. Now, in order to do this, there's a way you could solve it, but you could also just put some logic with it. If you say, I just can't grasp that logic, Mr. Soto. Well, what you could do is this. You could just not assume, but theorize that each of these were 60, because that would make a triangle. If these were each 60, what would it make each of these? And it doesn't matter what you make these. I mean, if you say, oh, they look exactly the same, that doesn't even matter. Whatever you make them, if you solve for the other ones, then you can, the sum of, you have to add this plus this plus this. So what do you think? And it wouldn't even matter. You could even have, this could be not to scale. And as long as you could say this is 20. I'm sorry, not this. Yeah, this is 20. And this is 110, even though it doesn't look like that. And that would be 130. So that'd be 50, right? Well, if that were the case, you could still solve for this, this, and this and add them together. And no matter what you do, you're still going to get the correct answer. But I would say 60, 60, 60 is about what it looks like because it kind of looks to me like an equilateral triangle. And then it makes all the same numbers on the outside for R, S, and T the same. And again, you could do this if you wanted to, but I think the 60, 60, 60 is the best way to do it because it's going to be the easiest way to do it. So I just said these are 60, 60, 60. Once I did, this is 120, this is 120, this is 120. So R plus S plus T is 120 plus 120 plus 120, 120 plus 120 plus 120. All right. Turn the page. Let's do a couple proofs together. These are the ones that really give us fits. That does not look like a right angle to me. Okay, I'm not going to redraw this shape because I will do it injustice. Maybe I should try to redraw it. Okay, the given is this. Let me get the letters out here too. Okay, they told us that this is a rhombus. They've told us that CU is perpendicular to BV and that CS is perpendicular to TV. They want us to prove that this line and this line, CU and CS, are congruent to each other. So I think the best thing to do, and I'm just going to think to myself, if I can prove how many are thumbs up if you're hanging on every word I say right now because you want to know how to do this so badly. 1, 2, 3, go. Okay. If I can prove, and I think I got it. I have the answer. I've not even looked at it yet though. But if I can prove that this triangle and this triangle are congruent, then I can also prove that the corresponding parts of the congruent triangles are congruent. How many understand my logic with a thumbs up? 1, 2, 3, go. Anybody confused on that logic? Thumbs down. Okay, now listen very carefully what I'm going to tell you. And I've not even looked at the answer yet. I have the answer here, but I've not even looked at it yet because I know exactly what I need to do. What I need to do is this: prove those two triangles are congruent. Once I prove those two triangles are congruent, I can prove that those two sides are congruent. Okay? Now, I know, I'm changing colors here. I know that this side and this side are congruent because it's a rhombus. It told me it's a rhombus. I also know that this angle and this angle would also be right angles. Is that correct? If the inside angle is a right angle, or if it's a perpendicular, this angle is also going to be a right angle, right? Perpendicular on both sides, right? Who remembers the theorem when you have the hypotenuse of a right triangle and the angle? There's a theorem. You have two triangles. They're both right triangles, and the hypotenuse, hypoteni, they're congruent. And remember what that theorem is? It's really just two letters, two words, but you can abbreviate in two letters. It's the hypotenuse leg theorem, right? Okay. So let me see exactly what they did to make sure we can write this out and do this together. And like I said, I do have this with me right now. Okay, so here we go. Statement, reason. And again, they give you a lot of this information on the teaching textbooks curriculum. So you don't have to create any of this. Just restate the given, which is the rhombus, and the perpendicular line. I'm not going to write it all. And the perpendicular line, which is the given. Point one is given. You have to state the given. Point number two, you got to say that the two angles are right angles. So I'm going to say CST, and I'm exactly right on my assessment. And I didn't even look at this. You say, Mr. Soto, you should be. And CUB are right angles. And I'm sorry that my penmanship's so poor here. This little tablet's really tricky to write on. So point two, you say that these two are right angles. And that's because perpendicular line. They said they were perpendicular. Perpendicular form right angles. So perpendicular lines form right angles. I'm abbreviating some of this. Okay, third thing. I can now say that CB and CT are congruent. Why? Because all sides of a rhombus are congruent. So now I've said there's a right angle here and a right angle here because of the perpendicular lines, because they told me they were perpendicular. The side here and the side here, because it's a rhombus, they told me it was a rhombus. Okay? So that's just definition of a rhombus. Oh, you know what? They didn't even use hypotenuse leg. They used a different one. That's okay. Then they said angle T and angle B are congruent because opposite sides of a rhombus are congruent. So T and B, they actually did it a little different way. They went this way. This and this are congruent because they're opposite sides of a rhombus. Opposite sides of a rhombus are congruent. So let's say 4 and T and B are congruent because opposite sides of a rhombus congruent. Again, sometimes there's more than one way to fry a fish. Then 5, all you gotta say is the triangles are congruent. Triangle CTSU. I'm sorry, CTS is congruent to CBU, I should say. And look, I said hypotenuse leg, which would have worked. They have angle, angle, side. Angle, angle, side. So AAS. Angle, angle, side. 5. Then 6, you've everything you need. CU congruent to CS. Why? Here we go. That acronym we learned. Corresponding parts of congruent triangles are congruent. Okay? So here we go again. They told us it's a rhombus. They told us that these two lines are perpendicular to these other lines. So I then conclude that these are right angles and that they're congruent. I conclude these sides are congruent because the rhombus. I conclude these angles are congruent because opposite angles of any parallelogram, including a rhombus, are congruent. So now I have Angle, angle, side, angle, angle, side. That proves the two triangles are congruent. If the two triangles are congruent, then the corresponding sides of the congruent triangles are congruent. All right, we're out of time. Let me just ask this question. I know I kind of went fast because we were running out of time. On that proof, did you understand like the mindset with they told me it's a rhombus, they told me there's perpendicular sides. I need to prove the two triangles are congruent because once I prove the triangles are congruent, I can prove that those sides are congruent because the corresponding parts of congruent triangles are congruent. So I got the angle, angle, side. Again, hypotenuse leg would have worked because the hypotenuse were congruent. They just chose to not do it that way. That's fine as well. A lot of times there's several different ways to do it. You could have done, you know, um, angle, side, angle, hypotenuse leg, angle, angle, side. Again, but so, anyways, on that, what do we think? Thumbs up, pointer finger in the middle if you're kind of confused, thumbs down if you're completely lost on those proofs still. Count of three, here we go. 1, 2, 3, go. All right. Okay. Again, I know the proofs are where we find a little bit of struggle, and but nobody's completely lost. And this will be on the YouTube channel if you want to watch it again, just to kind of refresh what we've done and such. So, but we're out of time. And so we will see you on Tuesday. And we're a week away from being halfway done with the semester, which is kind of cool. All right.